Today's lesson is called U-substitution. It's one of the method of solving integrals. You could think as a counterpart of the chain rule. So if you remember chain rule was dealing with something called composite function. So we're dealing with when y is equal to f of g of x. And we said y prime is f prime of g of x times g prime of x. And to make it easier to take the derivative, we used to call the inner function, which is a g of x, and we set that equal to u, so that derivative of u was equal to g prime of x. So we had y prime, and we solved it as f prime of u times du. Now we're going to go backward. So that backward is known as U-substitution. So since we're going backward, we're going to try to go back from this function. So now since we're trying to go backward, you write it as integral of f prime of g of x times g prime of x dx, indicating you're integrating the variable x. So remember, we're going to call u as g of x. So du has to equal to g prime times dx. So if you substitute those, we have integral of f prime of u times du, which means now the variable match, which leads to f of u plus c, allowing us to get integrals of composite functions. So now let's look at that as an example. Example 1. Find integral of square root of 2x plus 1 dx. So this is a composite function. Your inner function in this case will be 2x plus 1. So I'm going to call that a u. So our derivative of u will be 2 times dx. So instead of looking at integral of square root of 2x plus 1, we could think it as integral of square root of u times du over 2. Get this du over 2 because we have dx is equal to du over 2 by dividing 2 to the other side, substituting with dx. So now we could factor out 1/2. So we have integral of u to 1/2 power du. Now the variable matches up. We have u, we have du. We could integrate this using the power rule. So we have 1/2 times u to the 3 over 2 power times 2 over 3 plus c. So this will be 1/3 u to 3 over 2 plus c. Again, I'm putting as plus c because 1/2 times c is still will be a constant. Now we integrate it. We just have to substitute back in your original function and leave the answer in terms of x. So if you substitute, we get 1/3 times 2x plus 1 to 3 over 2 power plus c is your integral of radical 2x plus 1 dx. Example 2. We have x times dx over cube root of 1 minus 4x squared. Once again, our composite function in this case, your inner function is 1 minus 4x squared. So your derivative will be negative 8x dx. If you rewrite this in terms of u, we have u to negative 1/3 power x dx. Notice that it matches up with our du. We have du over negative 8 equal to x times dx. So we could say integral of u to negative 1/3 1/8 negative 1/8 times du is your integral. So I'm going to factor out 1/8 and integrate u to negative 1/3 power using the power rule. So negative 1/8 times u to 2/3 power times 3 over 2 plus c, negative 3 over 16 u to 2/3 power plus c. Now when you substitute back in your u, so you have your answer as in terms of x, 1 minus 4x squared to 2/3 power plus c is your integral. Now let's look at one more example. This time is with definite integral. We have x times x squared plus 1 to the 3rd power. So still a composite function. So again, nothing is changing. I'm going to start with integrating first. Your u in this case is x squared plus 1. Du in this case is 2x times dx. So we have integral of 1 to 3 u to the 3rd times x dx. We have 2x dx equal to du, so we could say x dx is equal to 1/2 of du. Just keep in mind these variable. Just keep in mind this number 1 and 3 is for the x, not for the u. So factor out 1/2. We have 1 to 3 u to the 3rd du. Integrate using the power rule. Since it's definite integral, we're going to try to calculate this from x equal to 1 to x equal to 3. The reason I mentioned this before is a lot of students make a mistake by substituting this into the u. Just keep in mind that 3 is for the x, so make sure you substitute back in your x before you solve it out. So your x in this case was x squared plus 1 to the 4th over 4, and you're solving this from 3 to 1. So 1/2 times 3 to the 2nd power plus 1 to the 4th over 4 minus 1 square plus 1 to the 4th over 4. So we have 1/2. 3 squared is 9 plus 1 is 10. 10,000 over 4 minus 1 squared plus 1 is 2. 2 to the 4th is 16 over 4. Okay, these could be subtracted. So we have 2,500 minus 4 1/2 times 2496, and if you divide that by 2, you get the answer of 1,248 as your answer. So just keep in mind, if your inner function, we're going to call that as g of x. And then we could say that integral of f g of x times g prime of x is equal to integral of f of u times du. Just make sure your variable match up. So if you have a function of u, make sure you have du instead of having dx. So find a way to get rid of the dx by balancing out with du.